Okay, so starting class number 4, we're going to talk about linear and rational equations. The preview exercises are typically going to be left up to you. Occasionally, if they're difficult, I will go over them in the demo portion of class. But today you should do them on your own. And this last one, C, is the one that's a little bit difficult, and we're going to start by doing that one together. So it is typically much easier to solve an equation that has no fractions in it. And it turns out that there is a way to solve linear equations that contain fractions without having to deal with the fractions. So the answer is that, or the technique we use is to clear the fractions. Call it clearing the fractions. So we start with the given equation. And then I want to multiply everything on both sides of this equation by 12. In this case, it's 12. And that's because it is the least common multiple, or the least common denominator, for those three fractions. Of 4, 6, and 3, the least common multiple is 12. So I multiply everything on both sides by 12. So I'm going to have x plus 1 over 4 equals 1/6 plus 2 minus x over 3. And I'm multiplying both sides of this equation by 12. All right, when I do the left side, 12 times x plus 1 over 4, the 12 over the 4 is actually a 3. So this becomes 3 times x plus 1. So 12, 4 goes into 4 once, and it goes into 12 3 times. You can do it like that too. And then I have to take the 12 on the right-hand side, and I have to distribute to both of these fractions. So when I distribute to the 1/6, 1/6 times 12 is 2. And then when I distribute the 12 to the second fraction, the 12 over the 3 reduces to 4. So I have 4 times 2 minus x. Okay. I'm just going to simplify a little bit. And I am no longer following all these steps on the right because we wrote out too many. Okay. So the next thing I'm going to do is simplify. So I have 3x plus 3 equals 2 plus 8 minus 4x. Just doing some distributing. Now I'm going to combine like terms. So I have 3x plus 3. 2 plus 8 is 10 minus 4x. And then I'm going to gather all my x's on one side and all my non-x's on the other. So if I add 4x to both sides, I get 7x. Subtract 3 from both sides, and I get 7. Divide both sides by 7, and I get x equals 1. There's my answer. We should check that x equals 1 is really a solution by plugging into the original equation, right, which was x plus 1 over 4 equals 1/6 plus 2 minus x over 3. So I should replace all my x's with my solution x equals 1 and make sure this equation is true. 1 plus 1 over 4. Does that really equal 1 over 6 plus 2 minus 1 over 3? Well, 1 plus 1 over 4 is 2 over 4, or 1/2. And then this is 1/6 plus 1/3. And 1/6 plus 1/3 is the same thing as 1 over 6 plus 2 over 6, which is 3 over 6, which is 1/2. So they are the same. It is definitely a solution. So we just solved the rational equation that had constants, 4, 6, and 3 in this case, in the denominator. Now we're going to learn how to solve rational equations where the denominators aren't just numbers, but maybe also unknowns, like x. So the procedure for solving these equations is very similar to the one we just did. We're going to multiply both sides of the equation by the lowest common denominator, but there's one very important difference. We have to remember to exclude any values of the variable that make the denominators 0. Okay, so before I even start, I look at all my fractions and say, are there any values of x that would make my denominator 0? Well, 1 over x is one of my fractions, so x definitely can't be 0. And then x squared minus x, I'm just going to do a little side work here. What would make x squared minus x equal 0? Well, I would factor out an x, and I'd get x minus 1. So x equals 0 or 1. So there are two values of x that cannot be solutions to this problem, because when I try to plug them in, I get 0 in a denominator. Okay, so I know that those can't be solutions, so I start working on finding the actual solutions. All right, so I've got 1 over x plus 1 over, and I'm making big fractions here, and I'm going to factor x squared minus x. Okay, so now I just want to build the LCD. I want these two fractions to have the same denominator. So if I want them to be the same, the fraction on the left is missing an x minus 1. So I'm going to multiply its denominator by x minus 1. And if you do the denominator, you always also have to do the numerator. And then this is a 5 over 1. And it's missing both an x and an x minus 1. Then I'm going to multiply both sides of the equation, every term on both sides, by the common denominator, x times x minus 1. And then all my denominators will cancel. When I distribute this x times x minus 1, all the denominators cancel on the left, denominators cancel on the right, and I just have x minus 1 plus 1 equals 5x times x minus 1. So this is just x equals 5x squared minus 5x. I'm going to get one side equal to 0 by subtracting x from both sides. And then I can factor out an x from the right-hand side. And then you can set each factor equal to 0. I'm multiplying two things together, and the answer is 0. So either x is 0 or 5x minus 6 is 0. This is not possible because up at the very beginning we said x cannot be 0. It's not an impossible solution. So I cross that out right away. And then I solve this other equation for x, and I get 6/5, same thing as 1.2. So that's my only solution to that problem. All right, so that's it. You should now start the class activity. Make note of any place you have questions, and be sure to ask me.